Hi everyone. Today we're going to study degrees and zeros of polynomial. Let's begin with degree of the polynomial. If p of x is a polynomial in x, the highest power of x in p of x is called the degree of the polynomial p of x. Examples, we have here four polynomials. The first is 4x plus 2. This is a polynomial in x. The highest power is 1. Remember that the degree of the constant 2 is 0. So in here, the degree is 1. Second polynomial, 2y squared minus 3y plus 4. This is a polynomial in y. And the highest power is 2 among the terms. So the degree is 2. Third polynomial is 5x cubed minus 4x squared plus x minus 2. The highest power is 3, so the degree is 3. Fourth polynomial, 7u raised to 6 minus 3 halves times u raised to 4 plus 4u squared plus u minus 8. This is a polynomial in the variable u. The highest power is 6, so the degree is 6. For the polynomial, when degree is 1, there is a special name for this, and we call this linear polynomial. When degree is 2, we call this quadratic polynomial. When degree is 3, we call this cubic polynomial. Let's go now to zero of a polynomial. If p of x is a polynomial in x, and if k is any real number, then the value obtained by replacing x by k in p of x is called the value of p of x at x equals k, and is denoted by p of k. A real number k is said to be a zero of a polynomial p of x if p of k equals 0. Example 1. Find the corresponding value of p of x equals x squared minus 3x minus 4 at x equals negative 1, x equals 2, and x equals 4. Let's begin with the value of the function at x equals negative 1. In symbol, we write p of negative 1. The function p of x is given here. So what we're going to do is we substitute all x by negative 1. So the x squared becomes the square of negative 1 minus the 3x becomes 3 times negative 1. Then negative 4. Simplifying the square of negative 1, we have positive 1. Negative 3 times negative 1 is positive 3. Then the negative 4. Simplifying this, we have now 0. This is the value of p of negative 1. Then we go to the next at x equals 2. In symbol, we write p of 2. Evaluating the p of 2, we're going to substitute all x by 2. The x squared now becomes 2 squared minus 3x becomes 3 times 2, then minus 4. We simplify 2 squared as 4 minus 3 times 2 is 6, then we attach the negative 4. Simplifying 4 minus 6 minus 4, we have now negative 6. Then we go to at x equals 4. In symbol, we write p of 4. We're going to substitute all x by 4. So the x squared becomes 4 squared minus 3x becomes 3 times 4, then the minus 4. 4 squared is 16 minus 3 times 4 is 12 minus 4. When we simplify, the answer is 0. These are the corresponding values of p of x when x equals -1, at x equals 2, and x equals 4 respectively. Since p of -1 equals p of 4 and both are equal to 0, then -1 and 4 are zeros of the polynomial. Example 2. Find the zero of the polynomial p of x equals 2x plus 3. Step 1. Let k be the zero of the polynomial. Then we evaluate p of k, which means the p of x here becomes p of k, and this is now the value, 2k plus 3. Step 2. We set p of k equals 0, and we solve for k. Our equation is p of k equals 2k plus 3. Now, this becomes 0. We can disregard the p of k, then we will solve here for k. This positive 3 we transpose to the right. We have now 2k equals -3. Then, isolating k, we divide the left side and the right side by the coefficient of k, which is 2. By doing that, the value of k equals -3 over 2. This is the final answer. Example 3. Find the zeros of the polynomial p of x equals x squared minus 3x minus 4. Step 1. Let k be the zero of the polynomial. Then we evaluate p of k. The p of x becomes k squared minus 3k minus 4. Then step 2. We set p of k equals 0. Then we solve for k. We copy our equation in here. Then this is equal to 0. We can disregard the p of k symbol. And from here, we're going to solve for k. We can solve this by factoring. And this becomes k minus 4 times the quantity k plus 1, then equals 0. We equate each factor to 0, which means the k minus 4 equals 0 and the k plus 1 equals 0. Then we solve for k for each of these equations. In the first equation, we transpose the -4 to the right. So the value of k equals 4. In the second equation, we transpose the positive 1 to the right. So k equals -1. These are the values and we call them zeros of the polynomial.